Okay, welcome to lesson 3.3 on the properties of logarithms. Today we're going to go through the properties, starting off with the product property, the quotient property, and the power property. So here it says let A be a positive number such that A is not equal to 1, because A is our base. Remember, any base of 1, any base raised to any power, that's if the base is 1, it's just going to keep equaling 1. Okay, n is a real number, and u and v are positive real numbers. Then the following properties are true. So for the product property, if we have the log base a of u times v, we can expand that into a sum. Log base a of u plus log base a of v. If it's the natural log, remember it's base e, so we write it as ln of u times v would be the natural log of u plus the natural log of v. For the quotient property, if we have the log base a of a quotient u over v, then that would expand to a difference. And the same for the natural log. For the power property, if we have log base a of u raised to the nth power, then what happens is that power comes out front and becomes the power times the log. Same thing for natural log. It becomes n times the natural log of u. Okay, the next one is change of base, which we already talked about in the previous section when we were talking about how you could enter this into your calculator if you don't have the format for a log. So this is the most commonly used one. If it's log base a of x, we can write that as the log of x over the log of a. But this is just showing that any base would work. So they're putting in base b, and in here they're using base e. So really either of these, we tend to use these because the common log button and the natural log button are right on your keypad of your calculator. So that's why we usually choose to use base 10 or possibly base e. It really doesn't matter what base you use. So write each log in terms of the natural log of 2 and the natural log of 5. So we're not using our calculators at all in this entire section. We're not getting any decimals. We're just doing what the instructions say and rewriting these in terms of natural log of 2 and natural log of 5. So first we have to figure out, we're going to play around with the numbers and see how we can use the 2 and 5. So in example A, think of that as the natural log of 2 times the natural log of 5. So since it's a product, we would expand that into the sum. Here we have 5 over 32. So I can think of that as the natural log of 5 over, think of 32 as 2 to the 5th power. Okay, so that's my fraction. So now I'm going to use the quotient property that turns this into a difference. So it's the natural log of 5 minus the natural log of 2 to the 5th. And now I can use the power property for this one and change that to the natural log of 5 minus, bring the power out front, times the natural log of 2. For this last one, let's see, there's a couple of choices here. If I use the quotient property, I'd have the natural log of 1 minus the natural log of 25. And the natural log of 1, this is saying e to what power equals 1. And we know anything to the 0 power is 1. And then I can change this to 5 squared. And again, use that power property. So I have negative 2 natural log of 5. So I'm bringing that power out front and multiplying. Okay, so let's look at a couple of examples of things that are done incorrectly. So why is this wrong? Take a good look at this. Why do you think this does not equal this? If you said because there's no parentheses around the AX, that's correct, right? So if we had this would expand to the natural log, or I'm sorry, just the log of A plus n times the log of x. And on this side, if we actually had n times the log, this would be, if we put it back, the log of ax to the nth power. Okay, number 2, take a look at this one and see what you think. Okay, if I have the difference of 2 logs, remember this becomes the single log of a quotient, x over y, not a quotient of the logs. So this is wrong. If I have log x over log y, if you look back at our change of base formula, log x over log y, that's from change of base. So this would actually be log base y of x. Okay, so expand each log. So here we have a product, we have the power. So this is the log of 3 plus the log of x squared plus the log of y. And then I can use the power property to bring that power out front. And there's my final answer. Now, if you have a root, remember that's the same as taking 4x plus 1. Square rooting is equivalent to raising to the 1/2 power. So that's how we're going to look at it. Now, 8 is a special number. I'm doing a difference because this is a quotient. 8 I can write as 2 cubed. So you're just going to have to recognize some of these numbers as a perfect cube or a perfect square. If you check your answer with the book's answer and you're not getting the same thing, then you want to look to see, did you perhaps miss one of the numbers that could be changed? Okay, like 8 for instance, if you just left it as natural log of 8. So here now we can apply the power property. So I bring the 1/2 out front. So it's 1/2 natural log of 4x plus 1 minus 3 times the natural log of 2. So your goal is to, again, break down any number that could be written as a base to a power and then use your power property. Okay, now we're going to go in the other direction and condense these. So when I see a number out front, I know that's going to become a power. So this is the log of x to the 1/3 plus the log of x minus 3 to the 5th power. And since it's a sum, that's going to become a product. And when I see this, you're going to change back to the root form. Okay, when you have a rational exponent, turn that into a cube root. So this is the log of the cube root of x times x minus 3 to the 5th power. If you wanted to, you could put an additional bracket around that. Okay, for letter B, again, we have a number out front, so that'll become the power, and the 2 out front, which will become the power. This is a minus, right, which will make this a quotient. So the numerator is the x minus 4. I'm going to keep parentheses around that, raised to the 4th power. And you don't have to multiply that out. And that's over x squared. So when you have a quantity like this raised to a power, same here. Okay, we're not expanding here. We're just leaving it as the quantity to the power. Okay, now here, notice this 1/5 is out front with the brackets around it. So the first thing I'm going to do is work on the inside. So since this is a sum, that's going to become a product. So I'm going to leave the 1/5 out front. And it'll be log base 3 of x times x minus 2. Now here, this I will multiply just to make it easier to write out, right? X squared minus 2x. And now I'll apply the power property. So it's this product, that's this, the whole product that's being raised to the 1/5 power. So it's log base 3 of x squared minus 2x to the 1/5. And then finally, I'm going to change this rational exponent back to the root. So it's log base 3 of the 5th root of x squared minus 2x. And now I can drop the parentheses because the root symbol is a grouping symbol on its own. So I don't need parentheses under the radical symbol. Okay. Next, we have some examples here that I want you to try. So these are from previous properties, 1 and 2. 3 through 8, you're using log base 10 of 5. Now this is kind of a strange way to write it. We usually just write log 5. So you can drop the base 10 if you don't want to, if you don't feel like writing it. And log 7. Okay. So again, this is the base. I'm not sure why they wrote it this way. Once in a while you might see it this way, but it's not very common. So you can drop the base 10s if you want and just write log 5 and log 7. So it says to use these two decimals to evaluate each expression. So again, we shouldn't be using the calculator. Now if you're going to use it to add up your decimals or multiply a decimal by a certain number, something like that, that's fine. But other than that, this is kind of like these problems here, except we didn't know the decimal values, so we just wrote it out this way. So you want to write it out this way and then do whatever it is you need to do with the decimals, okay, if you knew the decimal values for those. So in other words, I'll show you, we'll get started. We'll do number 3 together. So for number 3, now I'm working with 5 and 7. So if I have 35, and now if you're thinking product, yes, 5 times 7 is 35, but is that what I'm going to do with the logs? So this is log of 5 times 7. And when it's a product, it expands into the sum. So this is the log of 5 plus log 7. So I would add these two decimals together. So that's the idea. Here it's a quotient, so I would take the difference. So try 1 and 2 and try the rest of these. Pause the video, come back, and then we'll compare solutions. Okay, so let's see how you did. So for number 1, hopefully you got 3. And for number 2, hopefully you got 6. Yeah, those are again from properties from the last section. So here's the decimal answer from adding the two decimals. Here's the decimal answer from subtracting log 7 minus log 5. For 25, you can think of that as 5 squared, which becomes 2 log 5. So 2 times this decimal gives you this. The 490, think of it as 49 times 10, 49 is 7 squared. So I rewrote the 490 as 7 squared times 10. So that's 2 log 7 plus log of 10. And the log of 10 is just 1. So it's 2 times this decimal plus 1. For this one, I changed the fraction into an improper fraction, right? Remember, you multiply 1 times 7, add the 3, so it becomes 10 over 7. Since it's a quotient, it becomes a difference. So it's the log of 10 minus log of 7. And again, log of 10 is 1. So 1 minus the log of 7 gives you this decimal here. And then for number 8, think of this as 5 over 100. So it's the log of 5 minus the log of 100, and the log of 100 is 2. So log of 5 minus 2 gives you this decimal here. I'm not sure why I didn't circle that one, but all right, so I hope you enjoyed this lesson. If you have any questions, remember you can join me on Zoom any day. It would be nice to see you guys. If you want to just pop in and say hi, you can do that too. I'm there from 11 to 12. Okay, the ID and password is on the website. So you have some book assignments to do, so please complete those and hand them in through the assignments block on the website. Have a good day.